We code with stars, reaching for the sky. Each line of brushstroke, painting world.
Hi, stars. Welcome to our FastAPI Chronicles series on CodeStar, where we code with the stars. My name is Forster, and I'm here with you. Because you are the star. In our last video, we dove into setting up our development environment and created our very first FastAPI path. We walked through each step together, setting the stage for what's to come. If you missed it, feel free to check it out so you're up to speed, it's all there for you. Today, we're taking things up a notch as we explore the core of FastAPI, path operations. These operations are like the gears of your API, driving how it responds to various HTTP requests like GET, POST, PUT, and DELETE. Whether you're handling data retrieval or submitting new entries, understanding path operations is key to building a robust API. We're going to break it down step by step, ensuring you grasp the essentials and feel confident in applying them. So, let's dive in and start coding together. As always, I'm here with you every step of the way. Let's make it happen. In programming, a path or route is the specific path a client must follow to retrieve a resource from our server. In other words, it's the route a client needs to take to access a resource hosted on our server. Since we're building an API, for a client, usually a browser, to access a particular resource, they need to follow a specific path. For example, in the first path we created in the previous video, for a client to access the resource that returns the message "Hello World," they would need to follow the route path, which is simply a / after the base URL to get the resource that we placed there. If you're unfamiliar with terms like client and resource, don't worry, I've got you covered. A client is anything trying to access our API endpoints, that is, the resources, which is usually a front-end application accessing it through a browser. A resource, on the other hand, is the specific API endpoint we are building. Alright, let's dive into what makes a path operation in FastAPI tick. When we talk about path operations, we're essentially breaking it down into 4 key components. First, we have the decorator. Now, in Python, a decorator is like a little magical tool that can modify the behavior of a function or method. In FastAPI, our decorators start with the @ symbol and are tied to an instance of the FastAPI application. This is where the magic happens. It's what turns a regular Python function into an actual API endpoint that the client can access. Now, let's talk about the HTTP method. This is crucial. It defines the type of operation that the client wants to perform on the resource. The most common HTTP methods you'll encounter are GET. This is like saying, "Hey, server, give me some data." You're simply retrieving information without making any changes. POST. Think of this as, "I've got some new data, please save it." It's how you send new information to the server. PUT. This one's for updating. It's like saying, "I've made some changes, so please update the existing data with this." DELETE. As the name suggests, this is your way of telling the server, "Please remove this data, I don't need it anymore." If you're new to HTTP methods, don't worry, you can always look them up online for a deeper understanding. Next up is the path. This is the specific route that your client has to follow to reach your endpoint. It typically starts with a / and can be followed by more specific segments, like users. This path tells the server exactly where to go to find the resource. Finally, we have the path operation method. This is a Python function that does the heavy lifting. It performs the necessary operations and returns the result to the client. Whether this method runs synchronously or asynchronously depends on what you need to do before sending the resource back to the client. So, these 4 components, the decorator, the path, the HTTP method, and the path operation method, all work together to handle requests and deliver responses in your FastAPI application. Let's do away with the talking and jump into real action. We're going to put everything we've learned so far about path operations together. Let's create a path operation method that returns the message, "This is a path operation." We'll name it a path operation, but feel free to name it anything you like. We'll make it a GET request and set the specific path to path right after the root path. And there you have it, simple and easy. Huh? Next, we can go ahead and see it in action in the browser. Make sure you refresh the browser first, and then test the endpoint in the Swagger UI. Yeah, that's it, everything was successful. Let's do a quick exercise to help you grasp this concept. Change the path back to the root URL, then go to your browser and inspect the endpoints. Notice how the first root we created is no longer present in the Swagger UI. But go ahead and test it, you'll still get a response with "Hello, world." Magic, right? This happens because path operations are executed from top to bottom, so the first path that matches the root is executed first. Always make sure each path is unique and follows standard naming conventions, like starting paths with a noun in its plural form. Now, I'll change it back to paths in plural form and inspect it in the browser. Ta-da! Since we're diving into path operations, let me take this opportunity to explain two important concepts: path parameters and query parameters. Path parameters are part of the URL and are used to identify specific resources, like /users/user ID. Query parameters come after the question mark in the URL and are used to filter or modify the request, for instance /users name equals *. Since query parameters identify a particular resource in the server, they are always required fields. Let's create a path that returns a particular user from a list of user dictionaries. We'll name the parameter method pathParam. A user ID is supposed to be an integer, so we'll ensure the ID is an integer. Next, we'll use list comprehension to go through the list of user dictionaries and return the user with the particular ID to the client. For user in users, if user ID is equal to the ID provided, return that user. For the query parameter, we'll do the same, but return users with an age greater than what the user provides in the query. Alright, let's test this out in the Swagger UI. First, I'll check the path parameter for the user with ID 2. Look at that, there's the JSON response, and you can see the ID is tacked right onto the URL after users. Now, let's try the query parameter with age 33. As expected, it returns an empty list since none of our users are over 33. Go ahead and try it out yourself. Take a look in the Swagger UI and see how the curl command adds the query parameter. Query parameters can be optional, so I'll make the age parameter optional. To do this, I'll import optional from the typing module and use it. I've set the initial value of age to none, so if the user doesn't provide it, it defaults to that. Now, let's combine both query and path parameters. We're going to create another route that returns users with a specific ID and also filters based on the user's name. So, if I provide user ID 1 and name 1, I should get the first user in the list. You can go ahead and try doing this yourself, or just watch as I do it and then test it in the Swagger UI. We expect the user ID to be an integer, and the name to be a string, so I'll first check their types. Then, I'll use list comprehension to return the user that matches both the name and the ID. You can choose to make it synchronous or asynchronous, that's up to you for now. First, I'll test with a user that doesn't meet the conditions to see an empty list. Then, I'll test with user ID 1. Don't forget to check the optional parameter in the Swagger UI to confirm what we've learned. You can go ahead and create more path operations using the different HTTP methods to see how they look in the Swagger UI and get a feel for them. Try experimenting with more than one query or path parameter to see how they interact and how you can use them to create more dynamic routes. I'm creating a couple of examples, so you can use them as your reference. So, to summarize what we've learned today, we explored the key components of path operations in FastAPI, including decorators, HTTP methods, paths, and path operation methods. We also dove into path parameters and query parameters, seeing how they work together to make our APIs more dynamic and flexible. Creating a path in FastAPI is very simple and easy. What I love about this framework is the Swagger UI, which makes everything seamless and straightforward without needing any additional tools for testing. You have everything you need to build and test right at your fingertips. If you found this video helpful, don't forget to hit that subscribe button and ring the notification bell so you don't miss out on future videos. In the next video, we'll be diving into Pydantic models, which are super important for data validation and serialization in FastAPI. You won't want to miss it. And one last thing I love about this Swagger UI, the colors. Just look at the colors for the different HTTP methods. We're just paving the way for more advanced stuff in the future. In a real-world scenario, we'd use a database instead of a list of dictionaries. We'll get there soon. As always, keep coding, stay curious, and I'll see you in the next video. Until then, stay safe and don't forget, you are the star.